First, we are still under topic hydrostatic. Can you see the notes now? Husnia, boleh share dekat WhatsApp juga your answer tadi, so your friend can go through again later.
Okay, baik doktor.
Okay, good. So topic buoyancy, introduction and also principle of buoyancy, and followed by stability. So stability ni kita akan learn next class. So for today, only principle of buoyancy. Okay, the learning outcome at the end of this topic, you must able to formulate and also apply the principle of buoyancy for fully submerged or partially submerged. Okay, it can be fully submerged ataupun partially submerged. Okay, so we need to recall your physics. So why the boys have different face expression? So which one they feel heavy? Yang mana? Okay, the last one. Yang kat sini you can see the sweating. So bila dalam air, the weight akan berkurang due to the buoyant force. Okay, bila partially immersed, dia akan lebih berat. That's why the boy feel tired holding the rock ni, batu. Okay, so objective. So this is examples, experiment involve buoyancy. This one is to investigate the relationship between the weight and also the water displaced with the buoyant force. Okay, so sebelum ni belajar, kita ada dua types of the curve tadi kan? Displacing and also containing. So same for this concept. So displacing fluid ni sama dengan volume of the object, plasticine. Okay, it represent by the displaced water. So you can see from the spring balance, bila dekat luar, berat dia tinggi. Berat dia tinggi lah. So masuk dalam air, berat decrease. The weight decrease. This is high weight. Okay, another point that you should know, bila dia masuk dalam air, the density used to calculate this plasticine is 1000. Okay, outside the water, this density is represented by the density of plasticine. Okay. So weight is equals to the buoyant force, FB. Okay. The weight of water displaced is equal to the buoyant force. Okay, this concept follow Archimedes' principles. What Archimedes stated that for a body completely or partially immersed in a fluid, the upward buoyant force acting on the body is equal to the weight of the liquid it displaces. Okay, basically untuk soalan buoyant force ni, you also need to draw the full body diagram. Okay, how we draw? Contoh dia ada object, you kena tahu center of gravity, sama je. And then you should be able to draw the force. We have weight. Weight ni akan add dekat center juga. And also we have the buoyant force, FB. Okay, ataupun you can draw another way. You have center of gravity. So this is the weight. And this is the FB. Okay, drawing this, you get 1 marks for drawing. So we know that you understand where the force act. which is upward and also downward, and it at the center of gravity. Okay, so we calculate buoyant force as weight. That's why the formula is rho GV. Sebelum ni you kira weight sama kan? Rho GV is equals to vertical forces, FV. Still remember, you calculate FV using rho GV, and it also represent weight. Okay, so we have different condition here. So the first one, weight rendah, buoyant force tinggi. Okay, so bila weight rendah, buoyant force tinggi, dia akan rising, naik. Okay, second condition, weight tinggi, buoyant force rendah. So dia akan sinking to the bottom. Okay, and then condition of partially submerged, separuh saja yang tenggelam, it means that weight and buoyant force is the same. So we consider as floating. Okay, another conditions of floating, it is where the weight is equals to buoyant force sama juga. It can be fully submerged. Okay, untuk floating ada dua condition, fully submerged or partially submerged. Okay, what is buoyancy? Its definition is the vertical force exerted by the fluid on an immersed body. Okay, buoyancy equals to weight of displaced by the body. So the formula is rho GV, which is also represent the vertical forces. Density is density of liquid or fluid. G is 9.81 and VD is displaced volume of the liquid. Okay, what is displaced volume of the liquid? For example, you have a rectangle boat, dia immerse sikit saja. Okay, so dia punya volume adalah volume yang tenggelam sahaja. Okay, for example, dia bagi volume of the boat ni adalah tinggi dia 6, panjang dia 10, lebar dia 4. Okay, so you need to find the x here. Length yang tenggelam sahaja. You cannot, the volume cannot be 10 darab 6 darab 4, tak boleh. Okay, because we need to find the depth yang tenggelam to calculate the VD, volume displaced by the liquid. Okay, and then tadi saya sebut center of gravity. Actually untuk buoyancy, dia tukar sikit nama dia jadi center of buoyancy. But it is the same thing, which is it is center of buoyancy, where the point which buoyancy is acting and the centroid of the displaced volume of fluid. Okay, we have center of buoyancy. Here. Okay, this is buoyancy of different fluid. So kita ada density 1 and density 2. So we have center of buoyancy for each fluid. Okay, so FB must be act upward. So we have volume for density 1, volume displacement for 2. So we calculate density 1 times gravity times volume 1 and density 2 times gravity times volume 2 and we calculate the total upthrust. Okay, kita tak boleh mix because we have a different density. Okay, so this is the procedure we should follow to solve the problem regarding the buoyancy problem. So for concept of buoyancy ni ada soalan tak?
Ini tak ada doktor.
Okay. So ni saya mention tadi, you need to draw the full body diagram, the arrow tadi. So we can draw center of buoyancy. Upward is buoyant force. Downward is the weight. Okay, and then we make assumption total vertical force is 0. Kenapa 0? Sebab FB sama dengan W. Okay, so FB tolak W ialah 0. Okay, that's why we make assumption of vertical force is equals to 0. Okay, and then we need to solve the required problem by apply the buoyancy principle, which is FB equals to rho GVD. Okay, and then maksud kat sini adalah dia ada FB equals to W. FB ni buoyant force, jadi density dia ada density fluid, gravity, volume displaced. And this weight adalah weight asal sebelum masuk air tadi. So this is rho GV juga, but the V here is the V of the object. Okay, so let's see contoh. Contoh saya ada circle. Density of this circle object ialah dibuat daripada metal. So the density is 20,000 for example. And then the radius is 2. And dia float immerse partially. Okay, so dia immerse partially. Okay, how we substitute the information given, the value into this formula. So density of buoyant force ni 1000. Gravity dia 9.81. Okay, VD ni adalah volume yang displaced. So volume yang displaced adalah half of the total volume. Okay, so total volume ialah pi d squared, pi r squared. So R dia tadi 2. Okay, so kita tulis kat sini lah, saya tulis kat tepi pula. Okay, volume dia sebab dia tenggelam separuh. So we need to bahagi dengan 2. Pi r squared 4. Okay, and then ni density saya masukkan tadi. Dia kena density of this aluminium object. So dia punya density 20,000, 20k. Ataupun you write down 20 times 10 power of 3. Darab dengan gravity 9.81. And volume object is the full volume. Okay, pi r squared. Okay, macam tu. So FB dia punya volume adalah volume yang tenggelam. Weight, full volume of the object. Okay, and then we can also measure the depth of immersion kat sini using this formula, which is volume displaced divide by the area. Sekejap, saya ada error sikit. Ni saya kira area. What is the formula to find volume of circle? Sorry, dia ada salah sikit. Bukan volume. Pi d squared tu adalah area. Maybe we can darab dengan long ya. Dia akan bagilah width sama juga. Maybe width dia 4. Kat sini you darab dengan 4. Okay, because this is only the area. This total darab dengan 4. Okay, later when you go through the question, maybe you can more understand on this. Okay, let's see on the examples. So, W actual, ini adalah sebelum masuk dalam air. We can call it as weight actual. When it is inside the water, it can be weight apparent. Okay, so we need to calculate the volume of the stone. Then dia bagi the unit weight of the stone is 9.9803 Newton per meter cube. So we need to minus W actual to W apparent. So we get the buoyant force. And make summation of the vertical force is 0. So FB tolak W equals to 0. So FB ialah 245. The weight is rho GV object. So dia dah bagi the unit weight of the stone is 9803 darab dengan V object. So we can calculate the V object of the stone. Okay, unit weight ni adalah specific weight. Specific weight ialah 9803. So kalau you nak convert kepada density pun boleh. Ataupun you tak payah convert lah sebab specific weight ni formula dia adalah rho G. Sebab tu kita substitute rho G ni sebagai specific weight. Okay, if dia bagi density, you kena darab lah density darab dengan gravity. Then only you multiple with V object. Okay, let's see on another example. So this cube is 60 mm. So this one you boleh guna 60 mm sebab dia immerse fully submerged. For this one, you need to calculate the volume displaced sahaja. So the height is 40 instead of 60. Okay, we need to determine the magnitude and also direction of the force required to hold the cube completely submerged in glycerin. So you need to calculate what is the Fe inside the glycerin. So kita nak tukarlah daripada letak dalam air, nak letak dalam glycerin. Okay, first kita kena soft glue untuk water. So total volume ni VD. No, ni bukan total volume Kalau total volume kita tulis V object. So this is volume displaced, only this part. So 0.06 tukar kepada meter. Darab 0.06 darab tinggi dia 40 mm. Okay, and then make summation. Substitute into the formula rho GVD 1000 darab 9.81 darab 1.44. This is the buoyant force for water, inside the water. Okay, and then we move to glycerin. So you can see glycerin is fully submerged. So that's why the VD is V object, 0.06 darab 0.06 darab 0.6. Okay, and then we make assumption vertical forces is 0. So you can see from this arrow, kita ada 3 forces. So bila melibatkan 3 forces ni, sama je konsep dia. Bila sama arah tambah, different arah tolak. So that's why FB tolak dengan FE, tolak dengan W. Okay, sebab dia berlainan arah. So we need to find the FE. Masukkan semua nilai yang kita dah ada, which is FB and also W. FB adalah 1.413. So this one we calculate the weight. Okay, weight dia adalah density of the object bagi specific gravity. So specific gravity sama dengan ini kita nak kira density, sorry. So how we measure density? Density ialah specific gravity darab 1000. So 1.26 darab 1000. So you get 1260. Substitute into this one, 9.81. This is V object ataupun V object lah total. So 2.16. Okay, and then we can have the FE. Okay, and then next question, kita ada different fluid. So we need to split into 2. So you have FB for water and also FB for mercury. Last sekali baru tambah. Okay, and then dia dah bagi specific gravity untuk mercury adalah 13.6. And then dia punya submerge, 40% of its volume is submerged in mercury and 60% in water. So this buoyant force kena darab dengan 40% untuk water and mercury is mercury 40%. Water 60%. Okay, and we get the total of floating 100%. Okay. First, we need to calculate the weight of a full object, rho GV. So we use here the density of the metallic body. Okay, and then buoyant force for water, submerged in water. So the density, of course, water. And the volume ni 60%. 60% maksud dia 0.6 darab V. Okay, so we get buoyant force for water is 5886 V. V is unknown. And then we calculate the force acting when submerged in mercury. Density is density mercury. The volume is 40%. So we also have unknown V for submerged in mercury. And then weight equals to FB. So here we have 2 types of density. That's why we have FB1 and FB2. And then the weight is using this formula. Density here is the density of the metallic body. So you can refer to, dia tak bagi density of metallic body. Okay, so that is the unknown we need to find. Okay, and then we have the same unknown for V. So kita boleh settlekan sebab sama. Okay, so 5886V tambah 5336.4 bahagi V. V ni bawa ke bawah sini. Bring it here. So we can cancel the V. And finally, we get the density of the metallic body. Okay, this one is try yourself. You can try this one. So dia bagi full depth is 0.5. So we need to find the H. Depth that submerged. And the specific gravity of the wooden. Ni bukan specific gravity of water. This is specific gravity of the object. Wooden. Specific gravity untuk kayu. Okay, and then the wooden log diameter dia 0.6 and 5 meter ni adalah length dia. Panjang. Width. Okay, you can try this one. Okay, so senang je kan? Dia sama je konsep dengan vertical forces yang you belajar on hydrostatic forces tadi. Okay, so for now ada soalan tak untuk buoyant force?
Tak ada, Doktor.
Tak ada. So you boleh go through juga soalan-soalan tutorial and also past year. So next saya nak share untuk assignment. So you ada midterm break next week kan? So if you okay, you boleh buatlah time midterm break or you need fully rest, tak apa. You can buat during the class. Saya share sekejap soalan assignment. So untuk this time, you punya assignment, kita akan buat pertandingan. Okay, saya tunjuk pertandingan dululah. So you can bersemangat kot nak buat kan? Sebab ada pertandingan and the prize is money. So boleh nampak tak? Saya punya poster ni. Nampak?
Nampak, Doktor.
Nampak.
So this assignment, kita akan select yang terbaik untuk masuk ke pertandingan ni. So it is called virtual CDIO competition. So this is the important dates. Awak kena submit assignment ni pada 6 hingga 10 Disember. So you have berapa minggu 2 minggu lah kan? Midterm break and also you can do on week 7. Okay, and then kita akan select pada 10 hingga 16 Disember and judging pada 17 hingga 22 Disember and the winner announcement pada 29 Disember. So basically you punya video ni perlu disubmit kepada YouTube channel. YouTube channel ni bukan YouTube channel you. Dia adalah YouTube channel CDIO Virtual Competition ni. This one is untuk judging. So masa video submission ni boleh submit guna you punya video, you punya YouTube. So bila you all dah terpilih untuk masuk pertandingan ni, then only kita akan masukkan dalam YouTube CDIO Virtual Competition. So kalau you all nak tengok video-video pertandingan sebelum ni, you boleh tengok dekat CDIO Virtual Competition. Okay, dia ada YouTube And then the price, a winner is 300 and the most liked product akan dapat 100. So what is the challenge? The challenge is will it float, and this one is group assignment. So satu group maximum 4 orang. So cannot be more than 4, but boleh je less than 4. So what we should do, we need to design and produce a clay boat model that can float. Can float ni without load. Okay, so sebelum kita masukkan load, it must be floating dengan baik. Okay, tak boleh floating dengan sengit, tail, dah tenggelam sikit. Tak nak lah macam tu. Okay, and then we need to uji, test with the minimum berat of 200 gram. So basically 200 gram ni kita boleh represent guna duit shilling. So you can weight your duit shilling. So tengoklah 50 sen berapa berat dia. So berapa 50 sen boleh letak dalam you punya pontoon. We call it as pontoon ataupun clay boat. So highest mass loading to clay ratio will win the competition. Okay, that is on the poster. So we'll see on the question. Sekarang nampak soalan tak? Nampak tak soalan?
Nampak tak?
Nampak
Nampak.
doktor.
Okay, sekejap . Okay, so the learning outcome of this assignment is the student should be able to formulate problems related to buoyancy. Okay, so we have 20 marks in the total. Tapi carry marks untuk assignment is 10%. So it involves problem definition, problem analysis, plan development of the design, and also the plan implementation. So this is how you test the buoyant force and also the outcome evaluation. Okay, so the problem statement, design and produce a clay boat model that can float and also carry a minimum mass of 200 gram ataupun 0.2 kilogram. So duration dia sebenarnya 1 week sahaja, but I give you more time. Maybe you perlukan masa untuk pergi cari clay, or you need more time to discuss in group. Sebab previously kita buat seorang-seorang. So bila buat seorang-seorang tu mungkin senang lah. You need to handle yourself all the task kan. Kalau group ni kena bagi tugas sebab kita nak tahu person one buat apa, you need to describe. Orang pertama dia buat apa, orang kedua buat apa. So along the way untuk complete the assignment, we need to divide the task dengan baik lah. Okay, so materials, you can boleh dah mula cari material ni. We need non-hardening modeling clay. So ni clay biasa yang biasa adik-adik you all main. Clay tanah liat yang biasa tu lah. Biasa kan? Tengok tanah liat. Tanah liat yang kita panggil
Biasa doktor, biasa.
polystyrene
Biasa, doktor.
polystyrene ke apa tau, macam tu lah. Okay, and then we need a water tub. This one untuk uji buoyant force dia. And then coins, tissue paper, newspaper, beakers. We need a weighing scale. Ni scale, kalau mak awak rajin buat kuih mesti ada scale, weighing scale untuk measure berat tepung, gula. Okay, you can use that one. So boleh check lah 4 orang kawan tu siapa yang ada weighing scale. Okay, and then you need a ruler and measuring tape. This one nak kira berapa boat tenggelam, the immersion depth of the clay boat. And then you need a masking tape, maybe untuk label dia punya depth tu lah. Okay, and then you can replace this one to the suitable materials that available in your house, except untuk non-hardening modeling clay. Okay, material lain ni boleh tukar lah, kalau tak ada water tub mungkin boleh guna aquarium. If nak tukar coins kepada pemberat-pemberat yang lain pun boleh. Okay. Kecuali clay ni tak boleh tukar. You need to use non-hardening modeling clay. So you can follow this general instruction. So 4 members per group. Dia ada divided into 2 tasks, task 1 and task 2. Okay. You need to brainstorm the idea with your team members and provide the relevant task to each and everyone lah. So kena ada task, bahagian task tu. And then you need to show how you develop your plan to solve the problem tadi. And then draw the working flow chart for each step. If necessary, you need to tabulate the data and state any justification or assumption that you need to make for your floating body or pontoon. And then you need to record a video. Video ni less than 5 minutes. Okay, what we should include in the video, you need to show the dimension, diameter of the clay ball, you kena tunjuk lah. Berapa diameter your clay ball, and then the mass of your clay, and also the measurement of your boat. And finalize or test the clay boat with the coins tadi. Okay, and you also should answer this following question in the discussion, in your discussion later. So you kena buat dua lah, satu video, satu lagi report for your assignment. So report punya discussion perlu jawab yang ni. What is the volume of your water displays? What is the mass of water displays? You need to compare the volume and masses of the displays. And also explain why your object floats or fails to float. Okay. Okay, untuk task 2 ni you boleh fabricate your boat into your planning design. And the report should include introduction, workflow chart, design analysis, and also calculation, discussion, conclusion, as well as the reference. Okay, and the video you should upload to the YouTube. Deadline is 6 December midnight. So boleh submit guna Google Form. Saya akan bagi Google Form. So dekat Google Form tu you boleh bagi link of your YouTube video and also upload the report in PDF. Okay, later saya akan bagi front page dia. So, actually you can split PDF ni lah, you guna this as front page. Okay, this is the front page. You can masukkan all your group members name here with the student ID. Boleh ubah sikit kat sini. Student ID and also group member. Saya share video sekejap. Examples yang dah pernah buat sebelum ni. So you can backhill ataupun at least follow lah yang dah buat ni. Sekejap saya share. Salah pula. Share. Nampak tak video? Loading. Nampak Keluar tak suara?
I can't tell if you bought it, too stylish.
So you kena buat bola dulu. Tunjuk dia punya diameter. So either one, you can use ruler or you use the rope. Okay, ni sebelum jadi boat. Patutnya dia akan tenggelam lah. So we know the weight of the clay. Kalau you nak explain pun boleh Instead of writing the instruction ayat kat bawah tu, you can use your voice to explain the experiment. So you can make into a shape that you feel able to float nicely. Tak kisah any shape, any design. Ni boleh guna baldi lah kalau tak ada measuring. If you don't have the measuring jar ni, you can use your basin ke baldi. Okay, hopefully tak naklah tenggelam banyak sangat. Nanti nak letak coin, lagi tenggelam. So ni dah banyak dah tenggelam. Avoid this. That. Ni dia nak masukkan 200. Dia nak test dengan coin. Hello? Tengah kelas. Okay, bye. Boleh saya lajukan je lah, senang ni. Okay, bolehlah masukkan music, cantikkan video, anything lah sebab kita nak masuk pertandingan kan. Okay, you can use your creativity to make a interesting video. Or you can show the calculation. Calculation pun boleh masukkan. Okay, nanti saya tunjuk some video yang dah masuk pertandingan CDIO untuk semester lepas. Okay, ada yang masukkan sekali calculation dalam ni. You can make a calculation tu macam video jugalah. You type the calculation ke. Okay, use your creativity to add also on the calculation. Sekejap saya tunjuk calculation. Share file. Okay, ni sample calculation. Nampak tak calculation saya? Tak ada?
Tak ada doktor. Nampak.
Kat nampak video tadi sekejap saya share balik. You want to close? Yes. Again. Silap lagi. Ni. Nampak dah? Tak tahulah kenapa tak boleh share sekejap semula. Mana? Share. Macam ni lah share. Ni tadi saya tanya volume of circle tadi kan. So volume tadi kita guna 4/3 pi r cube Instead of using area direct width, you can use the volume of circle 4/3 pi r cube. Okay, and then you can calculate the volume of the clay. Boleh answer the question tu, what is the mass? Okay, include the explanation of why your object float or fail to float also. And buat diagram juga. Okay, this one you boleh tulis tangan ataupun you nak cantik lagi, you gunalah word kan, boleh type. Okay. That is the examples of the flowchart. Brainstorm the idea, you go to shop and buy the materials. Okay, and then you conduct task 1. You have the flowchart also. And task 2. And finally, you have the flowchart for the final report. So, flowchart ni boleh ikut creativity you. Kalau you nak satu flowchart pun boleh je. Okay, jadi ada flowchart. So, you include your outcome evaluation. So, masuk sikit explanation. Berapa boat you boleh tahan. So, this one dia boleh carry up to 205 gram of mass. Okay. Untuk outcome ni, you boleh buat itu table juga. So, maybe you boleh buat assumption lah. Kalau tambah berapa berat, tambah berapa depth. Okay, you can use assumption juga. Okay, that is the examples of what you need to include in the report. So, this one tak ada cover page. Nanti you tambah cover page lah. Okay, so untuk assignment ada soalan tak? Ada soalan ke?
Bila doktor?
Hantar 6 Disember, lambat lagi. So, you
Okay.
have 2 weeks to prepare. Tapi saya nak nama class rep. Apa class rep Najmi lupa lagi.
Itu saya doktor.
Azim, Dr. Azim.
Azim. Azim, saya nak list nama group hari ni
Okey doktor.
Okay. Boleh hantar kat saya.
Doktor, nak tanya yang clay tu banyak mana clay boleh letak?
Yang tu ikut you punya creativity lah. You nak clay berlainan warna ke, nak banyak ke. Yang penting dia nak kita boleh float dan juga boleh tampung berat 200 Newton. So maybe 200 gram. Maybe you boleh buat calculation sikit lah macam mana kita nak tahu berapa tinggi yang boleh kita tampung untuk 200 gram tu. Okay, sebab dia tak boleh bagi fix berapa diameter yang diperlukan. So ikutlah barang-barang yang ada kat rumah. Kalau baldi you saiz kecil, you mungkin kena buat kecil je. Okay, according to availability of the material at your house. So macam tadi kan, dia punya beaker tu kecil sangat. So kalau you ada aquarium ke, mungkin lagi cantik kan, you nak show the trial, nak tunjukkan eksperimen tu. Okay, saya rasa aquarium lah paling cantik sebab you boleh nampak kan dia punya depth. Kalau guna baldi kan kita ada berbanyak warna merah, hijau semua kan, so tak nampak lah. Susah you nak tunjuk dia punya depth of immerse. Okay, dia tak ada cakap kan kat sini berapa diameter. Roll your clay to a ball. Yang saya perasan sebelum-sebelum ni, student saya guna tiga clay tu. Ada juga yang tunjuk berapa banyak dia guna. So basically 3 lah, you can mix warna ke nak bagi cantik, anything lah. Use your creativity on that. Ada lagi soalan?
Doktor,
Ha.
yang pertandingan ni satu UiTM, satu Malaysia lah kan?
Ya betul. Semua.
Okay, doktor.
Okay. So kalau ada yang nak tanya on yang berminat sangat nak masuk pertandingan, sebab pertandingan ni kita pilih, bukan semua yang akan terpilih lah. Kita akan pilih yang best je lah yang masuk. Okay. So kalau siapa yang betul-betul berminat nak masuk pertandingan ni, mungkin you boleh PM saya bagilah idea-idea mungkin you boleh buat. C++ punya coding ke untuk dapatkan depth. Okay. We can add some creative punya information. How you calculate the buoyant force and also how you design the boat tu. Okay, bagi saya share dulu assignment ni dekat you punya group, takut terlupa. 3B. Saya share poster dengan instruction tu. Okay, so I think I stop here. Group name by today. Kalau ada soalan boleh je WhatsApp saya. Okay. Bye. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Thank you,
Thank you,
doktor.
doktor.
Waalaikumsalam. Thank you, doktor.
Bye.